Our last application in 3.5 day 2 is something called Newton's law of cooling, and it's a lot like what it sounds. Basically is, what happens to something if it's at a certain temperature and then it cools down. So what we've got here is a formula that you will need to know for this one. Now, on the test, I will provide the formula as you see it right here, but I won't have these descriptions around there. Those are things that you will need to know when you come in to take this test. So Newton's law of cooling, write down that formula to use for the assignment today, but here's what the different things mean. T sub m, that means temperature of surrounding medium. There it is right there. It's also right here, so it shows up twice in this formula. That has to do with what's around an object. So the most common thing for that would be like air temperature. That's a surrounding medium. Also, it could be if you put something in water, the temperature of the water would be the temperature of the surrounding medium. So that's T sub m. T sub 0 is the initial temperature of whatever object is in question here. So let's say you take a cake out of the oven. What's the temperature of that cake for the time being, right away as you get it out? T of t is the temperature. So maybe you take that cake out and it's 300 degrees, but then you test it a little bit later, let's say at 10 minutes, and it was 200 degrees. That would be the temperature of a cooling object at a specific time, at time t. So whenever you see this one in a problem, make sure that you are thinking about a specific time attached to that, and we'll definitely see that in the example. The other things here, we've got e to the kt, as you probably guessed, t is time. K is a constant that's determined by other values in the problem, so that varies from each problem, but it's constant for that particular problem. So what we're going to do is just jump right into the example, and it looks like this. It says here, a cup of coffee has cooled from 92 degrees Celsius to 50 degrees Celsius after 12 minutes in a room at 22 degrees Celsius. How long will it take to cool to 30 degrees Celsius? So we've got to identify some different things here, and the one I would start with is the 22 degrees Celsius, just realizing that's room temperature, so that's going to be our T sub m. That's going to be temperature of the surrounding medium. T sub 0 is the initial temperature of the object. So the object here, it says it cooled from 92 degrees Celsius. That was the initial temperature, so that's going to be T sub 0 is 92. And then the other one here is T of t. Now remember that T of t, I told you, is this temperature is connected to a certain time, and so we have 12 minutes as our time, and it cools to 50 degrees Celsius after 12 minutes. So that means 12 is little t, big T is 50 in this case. Now, what you're going to be doing in this process of Newton's law of cooling is you want to find out how long will it take to cool to 30 degrees Celsius. That's our eventual question, so that's T. We're going to have to find T eventually, but what we're going to do first is actually find this K value. That's going to be step 1 in this whole process, is to find K, because if we don't have K, we are not going to be able to find little t in the end. So I'm going to set up this formula with what we know for right now and solve for what we don't know. So T of t we said is 50. I'm going to put that over on the left hand side. Then Tm is 22, that goes here, plus T sub 0 minus T sub m. Okay, so that's 92 minus 22. And then the rest of the stuff over here is e to the negative k. We don't know what k is yet, but little t, we know, connected to the 50 is 12. So that's what we do next. Now we're going to have to solve this one. We got to solve this for k. So let's start by simplifying some things. We can say that, well, 92 minus 22 is 70. E to the negative, we'll go with 12k just to make that look a little better. It was 50. Now we have to get this e stuff by itself. We're eventually going to use some logs to solve this equation, but let's get the e stuff taken care of here by getting the stuff around it out of the way. So let's minus the 22 to the 50, then divide by 70. So that will give us 28 over 70 equals e to the negative 12k. Now, I left a little space here because there's something that we're going to do with this equation that we talked about with logs and exponentials as far as solving. We could reduce this fraction, but we don't really need to because we're going to do something with it next involving the calculator. And so the thing to remember is that if we want to get rid of an exponential, if we want to get this out of the exponent, what we got to do is introduce a log with the same base as what this base is. Well, log base e is ln. So I'm going to do ln on both sides. I've got to do the same thing to both sides. And so that means that over here, that on this right hand side, we're going to have the ln and the e are going to just cancel out and give us negative 12k. Now over on the other side, that's where we need to have the calculator step in to help us. And so we've got here ln of 28 divided by 70. Okay, so that's about negative 0.9163 will go. It's in our best interest to do a lot of decimal places in this problem, and we'll see why in a little bit. So let's go to 29 like that. Let's go that far. Then we want to take this, looks like we need to divide by negative 12 on both sides here. So divide that by negative 12, and we get 0.07636. Let's go to. Let's round that k value to 0.07636. 5 decimal places should be enough for our k value. So that's k, and we're going to use that in the next step to find out the actual answer to our problem. So we're going to take that k and we're going to use it over here. All right, so now here's what we've got. We already had t sub m, we already have t sub 0. We want to figure out how long it will take to cool to 30 degrees Celsius, and so that's going to be our new t of t. Now, as I mentioned, that's tied to a time, which is the question here. We don't know what the time is yet, so that's what we're trying to find. We just found the k value right here, rounded out to a lot of different decimals, and so now we will do step 2, and that is going to be find t. So this will be our last step. Now the formula is going to look pretty similar to last time. The formula, or the equation that we had, was right here. We're going to keep most of this the same, except for we're not going to have a t and we're not going to have a 50. We're going to replace those parts. So for t of t, we're going to put 30 on the left hand side. We had 22 for t sub m plus 92 minus 22, that's t sub 0 minus t sub m. E, now to the negative kt. Now we have a negative here. We now know k, which is 0.07636. T is missing in this case. We got to find t. So we're going to do it a lot like we did last time. We're going to start by getting rid of some of this stuff. We know that that's 70. We know this is 22, so we can subtract 22 and divide by 70, which is going to give us 8 over 70, leaving us with e to the negative 0.07636 t on this side. Like last time when we have e by itself, we want to get that out of there, so we're going to introduce ln to both sides. Again, we're going to let the calculator do some of the work here, but once we do this, it's going to be negative 0.07636 t, and then equal to, well, whatever that's going to be, ln of 8 divided by 70, negative 2.169. All right, so negative 2.169. And then we're going to divide both sides by the k value, by this negative 0.07636. So divide by negative 0.07636. And we get about 28.4. So now we finally get a number that actually looks like a reasonable answer to a problem. So 28.4 minutes. One thing I would really encourage you guys to do at the end of these types of problems is to look at that and say, does that seem reasonable? 28.4 minutes, yeah, I guess you could wait that long for something. If this were 284 or if it were 2000 or something like that, then you would know that we're looking at maybe a little bit of an unreasonable answer. So test these and just make sure that what comes out is a reasonable answer. And of course you can check them, you can look them up in your answer keys and all that sort of stuff. But I will promise you this, there will be one problem like this on the test that's coming up for Chapter 3. So make sure you know this process, and of course go back and look at the video again if you need to, or ask me questions anytime.